Alright guys, tonight we are going to graph exponential functions. And exponential means if you see like 2 to the x power. If the variable is in the exponent, it's an exponential function. So we're going to see what it looks like when we graph those. So an exponential function is a function where the exponent is the variable is the exponent. And they look like this. They're kind of like a curve. And if the base number is positive, it curves up. If the base number is negative, it curves down. If the base number is a fraction, it gets smaller. If the base number is a negative fraction, it gets bigger. That flips upside down. And the difference between the two graphs, this is called exponential growth, and this is called exponential decay. Growth, decay. Growth gets bigger, decay gets smaller. Okay? So, example 1, we're going to identify linear and exponential functions. We're going to tell which is which. Okay, so we need to say whether it's linear or exponential. So we need to know, how do we know if it's linear? How do we know if it's exponential? So linear functions have a common difference. I can spell. Okay. Exponential functions have a common ratio. Or, in other words, they multiply by the same thing every time. So the difference is we're adding or subtracting the same thing, and ratios we're multiplying or dividing by the same thing. So for A, you look at the y. What did I do to get from there to there? What did I do to get from there to there? And then what did I do to get from there to there? So it has to be the same. And what am I doing? Now, if you think adding first, I could subtract 2 and get to there, but if I subtract 2 again, it doesn't get me to -9, so it's not subtracting 2. So what if I multiplied by 3? Times 3, and then if I do that times 3, I get -9, and if I do -9 times 3, I get -27. So I'm multiplying by 3 every time. So you might want to write the words out. Multiply by 3. Common ratio is 3, play with the words. And so that means that it is an exponential. Now, why would I have written those words out? Right, because it says explain. That word explain means you need to use some words. I know this is math, but you've got words. You use them all the time. So you need to explain yourself. All right, B, y equals 3x. If the variable, the independent variable, which is 9 times out of 10 going to be an x, if it is not in the exponent, it is not exponential. So the variable isn't an exponent. Now you had two options. It was either going to be linear or exponential. But we know it's not exponential, so what must it be? It must be linear. Okay? So that's from a table. That's from an equation. If the variable is the exponent, it's exponential. If it's not exponential. And A, you look at either at the common difference or the common ratio. So, got it number 1 and 2. Do you got it? I want you to do number 1 and number 2. Number 1's a table. I want you to see if does it have a common ratio or does it have a common difference? Am I multiplying each time or am I adding? And number 2, I want you to look where the variable is. Alright, pause it, do your 2. I need you to answer with either linear or exponential, and then I also need you to explain why you said that. Okay? pause it, do those 2 questions on a sheet of paper. You can turn into me tomorrow and catch up with me on the next slide. Alright, example 2. We're going to use an exponential problem. When I say we're going to use it, I usually mean we are going to do a word problem. So we've got 30 flower beetles that are left in a warehouse. Their population doubles each week. So they give us this function that represents their population. How many beetles will there be after 56 days? And X is the number of weeks. Well, they give us this in days. So how many weeks is 56 days? So if you do 56 divided by 7, you'll get 8. So we're really looking for, instead of 56 days, we're looking for 8 weeks. Now, I know a lot of you, if you're doing that on a test, you're just going to put 56 in for X and see what you get. And that's going to be an answer choice, but it's going to be the wrong one. Alright, so you take 8 and you plug it in for X, because it says X weeks, and that's how many weeks we've got. So we're replacing the X with the number. So it's 30 times 2 to the 8th. And all I did was replace that X with the 8. And now you just do the order of operations. Exponent first. So that's going to be 30 times 256. And then multiply it by 30. So 7,680. And that's how many they'd have after 8 weeks. Gross. Okay. Got it, number 3. I want you to do the same thing. They give you the formula for the population. That's every half-year period. How many rabbits will there be after 3 years? So how many half years is in 3 years? So there's 2 and 1, 4 and 2, so 6 and 3. So I want you to put in 6 half years. So you're going to replace the X with a 6. Okay, go through and plug in the 6, do your order of operations, and then pause it, finish it, get up with me on the next slide. Example 3, graphing an exponential function. So we're going to graph this. Now, last year, I know if I said it once, I said it 50 times. You can graph absolutely anything I give you. With all the knowledge you have right now, you can graph absolutely anything I give you. All you have to do is make a table. Choose some X's, find your Y's, and put them on a graph. So that's what we're going to do. We're going to pick some X's. Remember, this is the process column, so we're going to put our function in there. 3 times 2 to the X. And then we're going to get a Y out. That's it. So pick some X's. Now, some teachers tell you pick -2, -1, 0, 1, and 2. And you can do that with everything if you want. Sometimes, though, it'll benefit you if you pick numbers that are going to work in your favor. So, let's see. I have to make these numbers exponents. So, little numbers are fine. That's probably what I need to do. It's -2, -1, 0, 1, and 2. So, we're going to do 3 times 2 to the -2. 3 times 2 to the -1. 3 times 2 to the 0. 3 times, 2 to the 1. And 3 times 2 to the 2. So Y is going to be 3/4. And you're like, whoa, Miss Richards, I don't know where you got that from. Okay, so let's do some scratch work. I erased that on accident. So scratch work. Let's do 3 times 2 to the -2. That negative exponent does what again? Oh, you forgot. Okay. The negative exponent pushes that number that it goes with to the other part of the fraction. So the 2 is going to go to the bottom, the 2 squared, and it's going to go over under 1. And you're still multiplying it by 3. Well, what is 2 squared? 4. So it's 3 times 1/4. And remember, you just put them both as a fraction, and then you multiply across the top and across the bottom, and you get 3/4. And Some of you can probably do that in your head. But that's kind of like the path you take to get there. Okay? And you might not have this luxury, but I'm going to erase my scratch work because I don't want it to look ugly. All right, 3 times 2 to the negative 1, that's going to be 1/2. Times 3 is 3/2. Oops. That's anything to the 0 power is 1. So 3 times 1 is 3. 3 times 2 is 6. That's 4. So 3 times 4 is 12. All right. Now that you've got this going on, hold on, let me grab a graph. Okay, there we go. Got a graph. Now we're going to graph those points. So if I was going to graph this point, I'd graph -2 on the x, 3/4 on the y. So we go left 2, and then up 3/4. So about almost to 1, but not quite. Over there. Okay. -1, and then we go up 3/2. So 1 1/2. 0 will go up 3. 1 will go up 6. And 2, you go up 12. That's way up there. I'm just out of the graph. And so you see you have this curve. So you'll connect it. And now you're not going to have a straight connection, but you can do it as well as you can. And then it's going to curve like that. This part's important. You have to know that it levels out. It doesn't keep going like that. It levels out. And that's your graph. That's all you do. You just graph it. Okay? So, got it number, well, this says 3, but it's not. Okay, fixed it. I want you to do these two. I want you to give me the graph for 4 and 5. Pause it, finish, and on the next slide I'll tell you how you can get up with me if you have a question. Alright, so if you have any questions or comments about tonight's lesson, you can email me, you can chat with me on Remind 101, you can talk to me on Twitter or Instagram, and you can go onto the Facebook page for this classroom and you can ask me any question you want. You can message me on there or whatever. And then don't forget to participate in the discussion on either Facebook or Twitter.